Hi, this is Elizabeth Lawrence, and I'm going to be talking about Lab 2, which is all about lines of charge. To start, I'm going to go with an introduction where I'm going to discuss the fundamental principles that we used in this lab, and then I'm also going to do a description of the lab and state any assumptions that I made, and then I'm going to talk about my calculations, where I did my measurements and setup, and then go through my hand calculations that I did. And then going through my code, I'm going to talk about the glow script model that I put in and some of the output and visuals that the code gave me. And then I'm going to talk about the conclusion, answering the what if and why questions, and also some concluding remarks that I have. So some of the fundamental principles used, I used Coulomb's law, Fe equals K Q1 Q2 over R squared, and the electric field of a point charge, which is KQ over R squared times the R hat. And then we're going to use the electric field of a rod, which is different from lab 1, where it's E equals KQ over R times the square root of R squared plus L over 2 squared times R hat. And then we're going to use the force due to gravity, which is, of course, F equals negative mg, where g equals negative 9.81 meters per second squared. And then we're going to do superposition and of electric fields. And then we're going to do line charges, which is where we are treating as a collection of point charges. So a little description of the lab. This is the same lab that we did in lab 1, where we were creating charge sections of Scotch or clear tape, and then following the observation of their interactions, we conducted an experiment to estimate the amount of excess charge on a single piece of the tape. And then our results that we had from lab 1 was that the tape will exhibit a positive charge, and it's drawn towards the pen with the negative charge, and the tapes demonstrate repulsion from each other because they are both positively charged. So the assumptions I made was that we are not treating the tape as a point charge, which is different from lab 1, where we did. The tape's charge is located at the center. Both tapes have the same amount of charge, and air resistance is negligible. So some of the measurements that I had, same from lab 1, the length of tape is 0.201 meters, the width of the tape is 0.031 meters, and the distance between tape A and B is 0.021 meters. And then tape A is the surroundings, and tape B is the system. So when I was calculating the net charge on one piece of tape, I had to draw my free body diagram first, and I found that the magnitude of gravity was going to equal the magnitude of the electric force. And then I set those equations equal to each other, solved for Q, plugged in my values, my measurements, and some constants, and then I found that Q was going to equal 2.16 times 10 to the negative 8 coulombs. I then plugged that into my glow script code, and I put my other calculations in there, and then I edited the equation for E field and glow script, put that in there, and it returned the electric field. And then here's some more code that I did where I had to update the scale for the electric field and the force through the electric field arrow. And then here's my output. And then it says that the magnitude of the electric force is 1.788 e to the negative 3, and the magnitude of the gravitational force is 1.962 times 10 to the negative third. And those are supposed to be equal, and those are pretty close to equal, so barring human error, but that looked good to me. And then here's some of the what if questions I had. What if I had modeled each of our tapes as a single point charge like I did in the previous lab? So I actually copied my work that I used from lab 1, which is where I found that Q is equal to 9.82 times 10 to the negative 9 coulombs. And then, of course, the one that I calculated for lab 2 was 2.16 times 10 to the negative 8. So not drastically different, but still a little bit different. And then the next question is, why do these estimates differ, and which value is more likely to be closer to the real value, and why? So the values differ because I used different approaches and different formulas to calculate the results. In lab 1, I treated it as a point charge, and then in lab 2, I did not treat it as a point charge, and I used the electric field from a rod. And then the lab 2 estimate is going to be more accurate because I didn't use the assumption that I was treating it as a point charge, and it's actually not a point charge in real life, so that's why it's more accurate. And the distributed charge model was a more accurate representation of the experiment I did. And then conclusion, it's the same conclusion from the last lab, where that objects with the same charges repel and objects with different charges attract. And when there's no other forces acting on the tape, the force due to gravity is equal to the electric force. We use Newton's second and third laws and Coulomb's law to find the charges, and the distributed charge model will work better to find the value of the tape's charge. And some possible sources of error that I had were human error and some of the assumptions I made, like ignoring air resistance. And that's it. Thank you so much for watching.